Hello, good evening everyone. I hope everyone is very good, everyone is very fine. So, how is the preparation going on? I hope it would be going very well. So today I'm back with the rapid revision session of the next chapter, that is thermodynamics and thermochemistry. It's a very important chapter. I hope everyone you know that, not just because this chapter has its own question that is coming from here, but because the things or the theories or the concept that is going to be used from here, right, in all different chapters. So chalo shuru karte hain without wasting any second. So now we will be talking about the basic terminologies of the thermodynamics. What are these? I hope everyone you know about. So that's why I have not kept them as the theory, like system, surrounding, universe. Everyone, cool. Next, what about the system and types of system? I hope everyone you know about open, closed, and isolated. What are the types of boundary between the system and surrounding in the open system or closed system? It is dithermic wall. While if it is going to be an isolated or insulated system, what will be there? So the type of wall that here used what? It is adiabatic wall. So I hope everyone you know about it. And then we are going to talk about, yes, that intensive and extensive properties of the system. Intensive properties are those kind of properties that does not depend on the how much of the matter or how much of the substance is there, while extensive is something that depends on how much of the matter or how much of the substance is there. Or you can say, if something depends on mass, it will be extensive, or if this something does not depend on mass, intensive. I hope it is very clear. So we are going to talk about few of the questions here, and tea placed in thermoflask is an example of. I hope you all have seen thermoflask. Let's say that, of course, there is no insulated system that you can say is ideal insulated system. There is no. But still, if you talk about thermoflask, of course, we have tried to make a system that will not have any heat or any mass transfer between the system and surrounding. And such kind of systems are called, of course, insulated or isolated system. So option C is the correct one. Next, which of the following is an example of open system? Human body. Of course, from the human body we can just exchange the energy as well as the mass. So human body is yes. The earth, for sure, yes. Of course, you know that here from sun we are absorbing the energy as well as we are radiating the energy. At the same time, every mass, energy, everything is being transferred. Bond, of course, the energy can be and energy as well as mass, all of them can be. So all of them are what? Examples of open system. So open system is those system through which you can exchange, or the system and surrounding can exchange the mass as well as energy. I hope you all know about it. Among the following, the intensive properties. Intensive properties are those properties that is independent on the mass. Let's see, mass itself, no. Volume, no. Or you can say here mass, or we also say it content. Mass, the more the content will be there, the more the mass will be there. The more the content will be, the more the volume will be there. Easy, right? Surface tension, but surface tension, either you take a small amount of liquid or a bigger amount of liquid, the surface tension is going to be same. So option C is the correct one. Enthalpy, all the types of energies are going to be extensive. If I talk about the examples, some important examples. Intensive ke liye the important examples are there. Surface tension will be there. There are a lot many are there, like refractive index, density, or viscosity. All the things that is having the, you can say, prefix molar or specific, like molar conductivity, specific conductivity, molar resistance, it's like you understand it, right? Or like molar heat capacity, specific heat capacity, those things. While extensive, if you talk about extensive, of course, mass, volume, area, then all the kinds of energies like enthalpy, internal energy E, or U, Gibbs free energy G, and all these things, entropy, etc. Like these things, I hope you understand it. Next, which of among the following state function is an extensive property of the system? Let's see, is there any? Temperature, yes. Intensive, temperature is something that is what? Sorry, just a minute. Is an extensive, sorry, I thought of intensive. Temperature is intensive. Volume, extensive. Refractive index, intensive. Viscosity, Intensive. Option B is the correct option. Next, which of the following is an intensive property? Again, intensive property. Density. Of course, we have seen that density. Always remember one thing. The ratio of the two extensives is intensive. How we can say? The mass by volume, it is also extensive. It is also extensive, gives density. It is what? Intensive. It's easy one, right? Or you can concentration, molar concentration. Think about it. The number of moles divided by the volume. Moles extensive, volume extensive, but the whatever is the result, that is molar concentration, that is intensive, right? Chalo, aage badhenge. Next, which of the following are not state functions? I hope, even though I have not told you, you know that from the first law of thermodynamics, Q plus W for a system will be equal to delta U. That is internal energy change. And for that, delta U is nothing but it is, I hope you all know that, state function or path function. It is state function. Q, path function. Work done is also path function, while H minus Ts is nothing but G. It is what? So G is nothing but it is state function. So remember something. What about the state function and path function? State functions are those properties, or you can say those functions, thermodynamic functions, that only depends on the initial state to final state. Initial state and final state. How do we define the state in thermodynamic system? In thermodynamic system, states can be defined as states defined by number of moles, pressure, volume, temperature. Generally, for us, right? So states defined by, and it is generally because we are going to talk about the gaseous system. What we are going to study about? Gaseous system, right? So here the state is defined by number of moles, pressure, volume, and temperature. So if there is anything, let's say there is a state A and something is going to B, from A to B. If you take any of the path, if there is a function that depends on the path, it will be path function. And we have two important examples of path function. W, that is work done, and Q, that is heat exchange. So Q and W are path function, while all other are state function. So what it is asking for? Not state function. 2 and 3. 2 and 3. Option A is the correct option. I hope it is all clear. While delta U, delta H, delta G, delta S, everything is, of course, you all understand it. It is state function. Topic: internal energy. What is this internal energy? Internal energy, everyone you know that. If there is any system, of course, that system will have some mass, some content will be there. Na? Without any matter, how can there be a system, right? So if there is some mass, of course, there will be some internal energy would be there. There would be some kind of interaction inside the atoms and molecules there. There would be some bond energy will be there. There would be some electrons that would be revolving. There would be many types, you know, all the everything is there. Nuclear energy is there. Many kinds of kinetic energies will be there due to the vibrational motion, translational motion, or rotational motion, whatever kind of motion it is, right? So that gives you what? It is nothing but, again, tell me, all these count for the internal energy, right? So what we can say, an internal energy can be represented by electronic energy, nuclear energy, like all these kind of energies. So basically, we all can convert that into internal kinetic energy and internal potential energy. So it is the whole delta E with E or U, that is internal energy. But for question solving purpose, we do not use E or U, but we use delta U. Is going to be important for us. It is going to be important for us. So chalo, let's talk about one question, just one question. Let's say you are giving, there is a system, a gas filled with, let's say there is a chamber filled with gas. If you give it velocity from outside, if you are making it, let's say this pen only, and this is the thermodynamic system, and if I'm giving this velocity from outside, so external velocity, will it give the kinetic energy? And that, yes, kinetic energy will be given. But is that kinetic energy going to help in increment in the internal energy? Yes or no? No. Always remember, only the internal kinetic energies will be counted, not the external changes. So external changes do not count. Understand it. Next. Now, mode of energy exchange. Always remember, there are two types of modes of energy exchange, that is work done and heat. What is energy exchange? Means work done and heat, basically they do not signify kind of, energy here, but they are going to be there only when there is some kind of exchange of energy from one type to another type, or one place to another place. So of course, if you want to change that state, so what you have to do? You have to, of course, you have to go through some path, and in those paths, whatever is the exchange is taking place, that will be only through two phase or two ways, right? So those transfer methods is only two. One is heat, one is work done. Now, if you talk about heat, heat takes place or transfer, you can say heat is the kind of mode that takes place when there is temperature difference, while work done is something that takes place when there is pressure difference or volume difference. What do I mean by pressure difference? Consider that there is a gas inside some system, right? Now, if there is some initial at equilibrium, whatever is P here, that same P is here. That's why it is there where it is. Like whatever is inside pressure, the same is external pressure. But what if the internal pressure increases? What will happen? It will start expanding. But what if the external pressure increases? It will start contracting. So this kind of whatever is the energy exchange is taking place, that is due to the work, and this is due to the pressure difference that you can understand, and this is due to, you can say, due to pressure gradient. I am being very, specific. I'm not telling that only the pressure gradient is one of the reason. No, electrical gradient may be there, anything may be there other than temperature gradient. But heat will always take place due to temperature gradient. Now, if you say what is gradient, the difference. If let's say that if at some point there is less temperature, at some point there is more temperature, and if both of the things get in contact, so whatever kind of energy transfer from more temperature to less temperature, that is nothing but that mode of transfer is heat, right? Understanding it. I hope you understand it this much. Heat and work can only be defined during a process, and it signifies absolutely nothing about the state. So it does not talk about the state. Thus, these two are path functions. Next, types of processes. What are the types of processes? I will come directly to the main point. There are two. One is reversible, one is irreversible. Reversible processes are slow processes. They are made up of infinitely small and infinite such steps, and all those steps will be, in all those steps, the equilibrium, the system will be having the equilibrium with the surrounding. So what happens? This process is very slow, and it takes place at a variable pressure. While if you talk about irreversible, it is a very fast process. A one-step process, or you can say finite number of steps are going to be there, and here in between there is not going to be any equilibrium. Yes, in the initial, yes, there will be equilibrium. At last there will be equilibrium between the system and surrounding, but in between no equilibrium. So what we can say, always remember the one thing that will be very, very, very important for you, that reversible processes take place at you can say variable, better we say variable pressure or external pressure condition. External pressure condition. While irreversible process at constant pressure. So how do you identify? Let's say in the question it is given that at constant pressure. So you will understand it means the process is irreversible, and if it is given variable means it is reversible. Dekho, every time it will not tell you in the question that whether it is reversible or irreversible. You will have to identify it. It's very, very, very important. Please note it down. Next, these things are there. It is for you. Please, you can just see that, stop the video and check it later on. Now, thermodynamic process. What are the thermodynamic processes are there? There are a lot many, and we will take few of them. Those are very important. And what I'm going to talk about here, I will be talking about the work done in all these systems, and work done as well as its relationship with Q and delta U, that is internal energy change. We'll talk about first law of thermodynamics, basically that says delta U equals to Q plus W. I hope without telling also you all know about it, that internal energy change equals to Q plus W, but it is only for chemistry. Please remember, it is for chemistry, not for physics. Not for physics. Chaliye aaiye. Isothermal process. The name itself suggests isothermal means temperature is constant, means there will be no change in temperature. So delta T equals to 0. If delta T is going to be 0, so what are the things that is going to be S is going to be 0? Always remember delta U, that is N CVM into delta T, it will also be 0, as well as delta H, that is N CPM into delta T, it will also be 0. So delta U and delta H is going to be 0. Please keep in mind for ideal gases. For ideal gases, delta U and delta H will be 0 if the delta T equals to 0. For ideal gas, make sure, but for you only the syllabus may ideal gases are there, so do not even think about anything. So if delta T equals to 0, so delta U has become equal to 0. So according to first law of thermodynamics, what we can say, 0 equals to Q plus W, Q equals to minus W. Now here, what is the work done? Always remember few things. Even if I have not told you what is the work done is something that is for chemistry. Work done in chemistry is going to be this minus of P external and integration of dV from V initial to V final. This is the work done in thermodynamic process. It is also called PV work. It is what? Pressure volume work. Please remember it. Agar if I just integrate it, what it will become? P external into bigger change in volume, that is delta V. That is minus of P external into V final minus V initial. Please remember, this is the work done formula. Always valid. Next we are going to talk about, so basically if you find out W, if let's say if work done in irreversible condition of isothermal, how much it will be? P external into V2 minus V1. This will be the formula. But what if I say work done reversible is there? What will be the formula? I think everyone you know that, minus of nRT ln V2 by V1, or we can say V final by V initial. It can also be translated into minus of nRT ln of P initial by P final. See, I have just changed it, V final by V initial, here P initial to P final. Why it is so? Because everyone you know that P is inversely proportional to V. Everyone, I hope these formulae will always be with you during the examination. Please keep in mind. So if you find out work done in reversible, let's say reversible condition is given, if you find out work done, then Q will be equals to just negative of work done. Let's say you find out work done in irreversible process given, the Q will be equals to negative of work irreversible. That's it. It's a very simple thing to do. Next, isobaric process. Isobaric process where the pressure, external pressure is going to be same all over. So this is the condition that you are in, right? Right now, what is there? Of course, the atmospheric pressure is there on your head. The same kind of process. So in such cases, there is nothing that you have to think about. Just delta P equals to 0. Whatever is first law of thermodynamics will be there. It will be looking beautiful, like what you know, delta U equals to Q plus W. Nothing is going to be 0 here. Next, isochoric process means delta V equals to 0. If delta V equals to 0, then work done will be, arey haan bhai, work done equals to minus of P external into delta V. So if it is 0, then work done will also be 0. If work done becomes 0, then delta U equals to Q. Okay, come bhai? Yes, of course. So what we can say, delta U equals to Q isochoric. Arey Q isochoric, what we say? QV. QV, so means heat exchange at constant volume, that is QV, and is equals to delta U. And it is, later on we'll talk about, it is NCVM into delta T. Please keep in mind, it's a very important relationship that we are getting here. So delta U equals to this, and it will be same as the Q. So here heat exchange will also be same. What else we can just think from here? What else we can think from here? So always think about it, that delta U is what? It is state function, while Q is what? Path function. How is it possible that both of them become same? Always remember, Q isochoric is also becoming state function. So in an isochoric condition, what will happen? The heat exchange will be a state function, not the path function. Keep it in mind, very important. Next, cyclic process. What are the cyclic process? Cyclic process where the initial state is same as the final state. It goes to infinite steps, doesn't matter. But if it comes back to from where it started, what we'll say? It is a cyclic process. So in cyclic process, how do we find out work done? So work done in such kind of process, work done cyclic is area bounded between PV curve and V axis or volume axis. Please take care about one thing, that is the unit change. What is the unit change? Units will be very important. Please keep in mind. 1 liter ATM equals to 101.3 joules or joules, right? And one, what else I should say? I think it is very important, and it is something that we have to keep in mind. 1 liter bar equals to 100 joules. So please keep these things in mind. Yeah, aega. Many times it will come here, right? So how do you do that? Now, always remember one thing. Let's say, because here there is no question, but still, can you see that? Let's say that there is some A, and it is what? B. It is going to A to B to, again to A. So what is happening here? It is the clockwise system. Can you see? Or you can say it is A and it is B. So can you see that here the whatever the process going, like it is clockwise. Let's say it is P and it is B. So if it is clockwise, so here if it is clockwise, then work done will be negative of area. Negative of area under the curve. What is the area under the curve? This is the area under the curve. Similarly, if it is, can you see, anti-clockwise? Anti-clockwise. If it is anti-clockwise, then work done will be minus here. Rather than becoming minus, it will become just equal to, just plus of area under the curve. Area under the curve. If it is anti-clockwise, whatever is area, that will be the work done. If it is clockwise, whatever is area, just negative. And it is for chemistry. Again, I'm telling you, chemistry mein work done ke liye just go negative, just opposite to the physics. That's it. Just for work done, not for internal energy, neither for heat exchange. Next, adiabatic process. What about adiabatic process? Adiabatic processes are those processes. Is there something else? No. Things that you have to keep in mind always, that here delta U equals to 0. If delta U equals to 0, then you understand it. What will be the first law of thermodynamics looking like? 0 equals to Q plus W. So therefore, Q equals to minus W. If you have found out the work done, you can find out Q, just negative of W. That's it. Simple, right? Chalo. Now here, after these things, you should keep this some other things also in mind, that all the state function or delta state function is 0. So delta H also 0, delta G also 0, delta S also 0. You understand it very easily. Right. Next, adiabatic processes. What is the adiabatic process? Where Q or heat exchange is going to be 0. If heat exchange is 0, so how the things will be looking like? Here, first law of thermodynamics looking like something like that. Delta U equals to W adiabatic, because Q is 0. But you understand it again. Delta U is a state function. Well, W is a path function. But always understand it. Once it is adiabatic, it is adiabatic process. In the adiabatic process, work done becomes state function. So this will also become state function. Please keep in mind. Next, the thermodynamic process in which the heat exchange between the system and the surrounding is not possible. So here Q equals to, delta Q equals to 0. So these are the things that you can keep in mind. And one more thing, always remember, work done in adiabatic process is less than work done in, or you can say mod of work done in adiabatic process mod of work done in isothermal process. Please keep in mind mod. Why am I using mod? Because of course, let's say that if it is expansion, in expansion it will be more negative and it will be less negative. So less negative is bigger than more negative, right? That's why I'm just putting it mod. Mod ke saath, you will only take care about the value, right? Whatever is the numerical value. So W adiabatic, mod of W adiabatic process is going to be less than mod of isothermal process. Please keep in mind, very, very, very important. And if somewhere it is given, why am I telling it? And graphs also sometimes given like that. See, so if you see P, if it is V, chalo, there are two processes. Let's say it is asking for A, it is going to B, and it is going to C. Can you see that this is the more area, while this is the, you can say, this area is the smaller area. If it is smaller area, you can say that this is for, it is for adiabatic, while this is for isothermal process. And one more thing, always keep in mind, in adiabatic process, always keep in mind, if expansion takes place, then cooling also takes place. If compression takes place, then heating effect takes place. Always keep in mind. Yaar, ye bahut important. It's very, very, very important point to keep in mind. Next, work done in adiabatic reversible expansion. Always keep in mind, if reversible expansion, then you will use gamma. What is gamma? This gamma is nothing but Poisson's ratio. Poisson's ratio. W equals to NR delta T, that is T final minus T initial divided by gamma minus 1. So when gamma is Poisson's ratio, which is equal to Cp by Cv, and Cp minus Cv equals to R. So always remember Cp, basically it is somewhere in chemistry's language it is wrong. Cpm minus Cvm equals to R. Basically Cp minus Cv equals to NR. N here the number of moles of gases. Keep in mind. Keep in mind, please, very important. So if we put the value of gamma, we get the expression for work done. W equals to NCV T final minus T initial. Okay. So work done equals to NR T2 minus T1 divided by gamma minus 1. For what? For work done reversible in adiabatic process. Next, for what about the irreversible? Irreversible expansion, with no tension. Always use the same thing, because Q equals to 0. So delta U equals to W. Delta U equals to N CVM into T final minus T initial. Just you use it and get that. So P external into that same thing. P external into same thing. P external, then you just put all these values. What is from where this is coming? Because everyone you know that PV equals to nRT. So from here, volume will be coming from is equal to nRT divided by P. So basically how it is coming? V1 will be equals to nRT1 by P1. V2 will be equals to nRT2 by P2. We have just kept it here. Got the answer. That's it. Simple. Next. One more thing I would like to tell you from here. If it is reversible adiabatic process, then you should know about the relationship between or among P, V and T. Very important. Students generally just use it for adiabatic process, not for adiabatic. It is for reversible adiabatic process. Reversible, not for irreversible adiabatic process. P, V power equals to power gamma equals to, here gamma is what? Poisson's constant, equals to constant, and TV power gamma minus 1 equals to constant, or you can say P power 1 minus gamma, T power gamma equals to constant. That's it. Remember it. Important. Next, what is the correct about isothermal expansion of ideal gas? Okay, isothermal process of so always remember, work done in reversible process is always greater than work done in irreversible process. If somewhere it is given work done maximum is means it is trying to tell you that it is isothermal reversible process. So work done in isothermal reversible process is what? W max. If somewhere it is asking what is the maximum work done, means it is telling you indirectly, yeah, it is isothermal reversible process. Just use the formula. What is that? W equals to minus of nRT log of ln, that is V final by V initial. And everyone, I hope you know that ln equals to 2.3, ln x equals 2.303 log of x. So this is something that you can use everywhere, right? Here, so what is there? W reversible is more than W irreversible. That's correct. Next, free expansion. What is free expansion? Free expansion is those where there is no external pressure that it can expand freely. Yes. So means you can say when there is no external pressure, when there is vacuum. So expansion of a gas in vacuum where P external equals to 0 is called free expansion. No work is done during free expansion. So always remember, work done equals to 0. Why? Because P external here becomes 0, and work done equals to minus of P external into delta V. If this becomes 0, work done will also become 0. But what if it is going to be, if adiabatic free expansion is taking place, then what will happen? Then work done will also be equal to 0, and because of adiabatic Q will also be equal to 0. So delta U equals to Q plus W. If both of them are 0, then delta U will also be 0. So here in this case, everything will be 0. Always keep in mind, bhai. So these are the points. These are the, diamonds. These are the diamond points, bhai, not just the golden points. Like 3 moles of an ideal gas expanded spontaneously into the vacuum. The work done will be spontaneously into vacuum. Vacuum में अगर हो रहा है तो of course free expansion 0. Answer. Next, which of the following is correct option for free expansion of an ideal gas under the adiabatic condition? Abhi to baat ki bhai, everything is 0. So everything is 0. Next, first law of thermodynamics. What is first law of thermodynamics? I hope everyone you know that it is nothing but it is the another way of telling the law of conservation of energy. What it says that energy can neither be created nor be destroyed, although it may be changed from one form to another form. How do you say it? Delta U equals to Q plus W. So if internal energy of any system can be changed by either working on it, or when it works on the surrounding, or by giving the heat to it, or if it gives the heat to outside the surrounding, yes or no? These are the two ways, right, with which you can increase or decrease the del U, that is internal energy. So from this statement follows that total energy of the universe, that is, okay, leave it. That's not a very much, I'm not interested into it. Next, now we are going to talk about the sign convention. Let me tell you, very, very, very important. If you keep in mind, always remember, for chemistry, not for physics, for chemistry, because if work is done by the system in chemistry, it is positive, negative, while in physics, if the work is done by the system, it is positive. But here is just opposite. If the work is done by the system, it is negative. If work is done on the system, then it is positive. Please keep in mind. So Q, what is Q? If the heat is taken by the or absorbed by the system, positive. If it is released by the system, negative. So positive sign means system gains heat. Negative sign means system loses heat. Work done means work is done on the system. Negative sign means work done by the system. Delta U means the net gain of the energy by the system, means net loss of. I hope it's very, very understandable and known point, right? System absorbs 100 kilojoule of energy, means what we can say, Q equals to, absorbing means positive or negative, positive 100, and does 130, does, who is doing? System is doing the work. So negative or positive? Negative. So work done equals to minus 30. So what it is asking for? Net change in internal change. Delta U equals to Q plus W, that is plus 70 kilojoules. Next, under isothermal condition, a gas at 300 Kelvin expands from 0.1 to 0.25 liter against the constant external pressure. That is constant external pressure. Constant external pressure means reversible or irreversible. I told you, they will never tell you irreversible or reversible. You have to find out whether it is reversible or irreversible. Constant means it is irreversible, and it is what? At constant temperature, isothermal bhai. What will happen? Work done equals to minus of P external V2 minus V1. Chali bhai, next, P external is how much? 2 bar. V2 is how much? 0.25 minus 0.1. How much it is? Minus 2 into 0.15. That is minus 0.3. But it is what? Bar. Here, pressure is what? Bar. While volume is what? Liter. So it is what? Liter bar. Liter bar, I know that how to convert it into joule. 1 liter bar equals to 100 joules. So what we can say? Multiply with 100. How much it will be? Minus of 30 joules. Minus of 30 joules. Is there any option? Yes. A. Next, a gas is allowed to expand in a well insulated. Well insulated means adiabatic. Well insulated means adiabatic process. Adiabatic. If adiabatic process is there, so Q equals to 0. Container against a constant external pressure means it is reversible or irreversible. Again, it is what? Irreversible. Of 2.5 atm from an initial volume of 2.5 liter to final volume of 4.5. So it is what? V2. It is what? V1. So the change in internal energy, delta U of the gas in joules. Very easy. So what we can say? Delta U will be Q to 0 ho chuka hai. Q is 0. So it will be equal to W. And you know that work done in irreversible process will be minus of P external into V2 minus V1. That's it. Yes? Yes or no? I told you that P delta, that whatever is you have told you, and R delta T by gamma minus 1. It is not for reversible. It is for irreversible adiabatic. Because it is irreversible. It is not for irreversible. That was for reversible. It is for irreversible. So how? Let's see. Minus of P external. P external is how much? How much is the external pressure? 2.5 atm. Please keep in mind the value. These units very important to keep in mind. V2 is how much? V2. Volume 2, 4.5. 4.5 to 2.5. V2 minus V1. It is liter atm. That is minus 2.5 into 2 that is minus 5 liter ATM. So minus 5 liter ATM, 1 liter ATM equals to how much? 101.3 or 101 joules, almost you can say, right? So multiply it with 505 joules will be the correct answer. Minus of 505 is the option C. Enthalpy H, enthalpy change, that is delta H. Always remember, enthalpy is nothing but it is the total energy of any system. What is the total energy of any system? Just keep in mind whatever is inside and whatever is coming from outside, right? So basically, for existence of anything, it has to have a very, it has to have a conversation with the surrounding. Okay, I will put some pressure. Just for my existence, I need to put some pressure on you, and that is called PV energy. And the one part is what? Internal energy. So if you add both of the energies, you will get H. That is what? The total energy. That is also called as enthalpy. But we are not going to deal with enthalpy, but we are going to deal with the enthalpy change, that is delta H, for our question solving purpose. That's very important to know, right? So here, always one more thing, always keep in mind that delta H is nothing but QP, that is change in heat at constant pressure, that is NCPM into delta T. Always keep in mind. So delta H equals to QP, that is NCPM into delta T. What is CPM? CPM is nothing but it is heat capacity or molar heat capacity at constant pressure. Please bhai ध्यान रखिएगा. Next, what is the final formula? Delta H equals to delta U plus P delta V. इसी को थोड़ा सा translate कर दो and you will get delta H equals to delta U plus delta Ng RT. Ardha Mahindi or not bhai? So delta H equals to delta U plus delta Ng RT. What is delta Ng? Delta Ng is nothing but change in the number of gaseous moles. Change in the number of gaseous moles. So delta Ng equals to number of gaseous product minus number of moles of gaseous reactant. Please keep in mind. Next, always remember, if delta Ng is greater than 0, then delta H will be more than delta U. If less than 0, then delta H will be less than delta U. If equal to 0, then delta H will be equal to delta U. Please keep in mind these points, all the points that I am writing externally, extra I am writing, very important, or directly question comes from there. Next, consider the velocity, the reaction this carried out in the constant temperature and pressure, means of course pressure. Delta H and delta U, everyone you know that. Which of the following is the expression true? What we can say? What is the delta Ng? It is asking for the relation between delta H and delta U. Just find out the delta Ng. What is the delta Ng? Delta Ng, the number of reactant, gaseous reactants. Of course, ammonia is a gas, hydrogen is a gas, nitrogen is also a gas. How much is the reactant product? It is 2. What is the reactant? 3 plus 1, 4. So 2 minus 4 is how much? Minus 2. If delta Ng is less than 0, so delta H is less than delta U. Delta H is less than delta U is option C. Next, option for the following. For the combustion of 1 mole of liquid benzene, we have taken the benzene in the liquid form, no issues, okay. At 25 degrees, the heat of reaction at constant pressure is given by, okay, at constant heat at constant pressure. What is this? QP. QP, and QP we have told you is delta H. So delta H की value कितनी दे रखी है भाई? Here, these many. So it is delta H की value this much. It is only given. What would be the heat of reaction at constant volume? What is heat of reaction at constant volume? It is delta U, that is QV. Just right now we have studied about it, right? So what is the relationship? Delta H equals to delta U plus delta Ng into RT. I hope you all can do it. Delta H is already given. You have to find out delta U. What is delta Ng? Let's find out. What is the number of moles of gas in the reactant side? 6. What is the number of moles of product? Product is 6. So NP, so delta Ng will be 6 minus 15 by 2 is how much? 7.5. It is how much? Minus of 1.5. So delta Ng is how much? Minus of 1.5. What is the R key value? Because here delta H is given in calorie. In calorie, R key value is how much? R will be 2. What will be the temperature? Temperature should always be in Kelvin. What is the temperature given? 25 degrees. So 298 Kelvin. Please keep all these values and get the delta U. Not a big deal, right? It is all done. So please remember the R key values. R key value 8.314 joule per mole per Kelvin. It is equals to 2 calorie per mole per Kelvin equals to 0.0821 liter ATM per mole per Kelvin. Need to remember it. Next, relation between Cp and Cv for an ideal gas. What is the Cp and Cv? I hope you understand it. It is the heat capacity at constant pressure. It is heat capacity at constant volume. Chaliye, Cp minus Cv equals to nR. Yes, here it is written correctly. Only for the ideal gas. That is Mayer's relation. But if it is molar heat capacity at constant pressure minus molar heat capacity at constant volume, that is Cpm minus Cvm, it is equals to R. Please keep in mind. Next, molar heat capacity. Next one more relation is there, that Cp by Cv, that is also equal to Cpm by Cvm. It will be equal to gamma, that is nothing but Poisson's ratio. What are these things? Ab ye cheeze, it all for the longer batches, right? Not for the rapid revision. Just remember one thing. How do we get this Cv? It is equals to, it will just take a lot of time. Fr by 2. Fr by 2. What is this degree of freedom? How to find out degree of freedom? It's a completely, I need to tell you in taking time. We do not have that much of time. For monoatomic, what is that value? Just keep in mind, it is 3R by 2. Excluding vibrational, not the including vibrational freedom, degree of freedom. No, we are not going to take the degree of freedom. It is what? Degree of freedom. Here, Cp is what? Cp is equals to Cv plus R. You have to keep in mind. So whatever is there, plus 1, 5 R. And always take excluding vibrational, not the including one. Because we do not include for finding out gamma. So for gamma value will be 5 by 3. That is how much? 1.6. How much it is? 1.66. For monoatomic. For diet is how much? 7 by 5. That is how much? 1.4. For triatomic, if it is linear, it is also 1.4. But if it's triatomic, it is non-linear, it will be 1.33. Chaliye bhai, aage badhenge. Always remember, these values are applicable at low and moderate temperature only, not for the very high one. Next, an ideal gas, Cv equals to given 3R, expands adiabatically. Adiabatically means Q equals to 0 into a vacuum. Arey, vacuum means work done is also 0. Arey, vacuum ka matlab P external becomes 0. P external becomes 0, so therefore work done also becomes 0. It's doubling its volume. So V2 has become equals to 2V1. The final temperature is given by. Okay, let's think about it. Okay, what is final temperature? But before that, think about the first law of thermodynamics. Everyone, you know that delta U equals to Q plus W. And Q has already become 0 because of the adiabatic process. W has also become 0 because of P external equals to 0. So therefore delta U equals to 0. That is N CVM into delta T. Arey yaar, if this is 0, so this whole will be 0. So what we can say? Delta T equals to 0. So T final minus T initial will also be 0. So T final will be equal to T initial. So what is that? Both of them are same. Easy one, right? An ideal gas with Cv equals to 3R expands adiabatically under variable external pressure condition, doubling its volume. Okay, यहाँ पे ध्यान से देखो. It is adiabatic process. Very good. So Q equals to 0. Variable external pressure. Arey, variable external pressure condition means, variable bhai, means it is talking about reversible or irreversible? Reversible process. If it is reversible process, तो वहां पर हमने जाना है, yes or no? Doubling its volume, the final temperature is given by. So it is giving something about volume. Doubling it means V2 equals to 2V1. Arey, same kind of question is there. Just one thing it has changed. External pressure. It is variable external pressure. So if it is reversible adiabatic process, what is the relationship between volume and temperature? Remember, PV power gamma. I told you for the relation between P, V and T. For reversible adiabatic process, what is the relationship between T and V? T, V power gamma minus 1 equals to constant. Or you can say T1, V1 power gamma minus 1 equals to T2, V2 power gamma minus 1. What is the gamma value? Gamma Cv is given this one. So Cp will be equals to Cv plus R. That is how much? 4R. Okay. So what will be gamma? Gamma equals to Cp by Cv. That is 4R by 3R. That is 4 by 3. Keep it 4 by 3. So gamma equals to 4 by 3. T1 is given. How much? How much is the temperature given? Achha, it is asking for the final temperature is given. Okay, no problem. So T1 is something T, let's say. V1 is how much? Let's say and we all know that V2 equals to 2V1. Here it is given. V1 power, keep it gamma minus 1 only, equals to T2. We don't know how much it is, into V2 is how much? 2V power 3. Leave it gamma minus 1 only right now. What we need to do? We need to find out the relationship between T1 and T2, right? Let's find out. T2 by T1 will be equal to V1 1 power gamma minus 1 by 2 power gamma minus 1 into V power gamma minus 1. Cancel. 1 by 2 power gamma minus 1. So what is gamma ki value? Gamma ki value is 4 by 3. So 1 by 2 to the power 4 by 3 minus 1 is how much? 1 by 3. That is 2 to the power minus 1 by 3. So what we can say that T2 equals to 2 to the power minus 1 by 3 into T1. Is there any option? Here it is. Next. Yeah, dhyan rahe. See, I'm being fast, but the thing is that it's all doable, right? Entropy. What is entropy? It is the measure of the randomness or disorderness. What it depends on? Factors. And what is the formula? Delta S equals to Q reversible by T. It is not inversely proportional to T from here. Do not think about it. One more thing, the factors affecting entropy. Whatever I'm writing, please note it down. That first, let's say if it is phase. So what we can say for entropy, gas is more than liquid is more than solid. Of course, you know that in the gases there are more randomness. Second, temperature. If temperature is increased, of course you see that if somewhere the temperature increases, things become random. So what we can say, as the S is directly proportional to T. What about the third thing? That is moles. So always remember, because entropy itself is a extensive property, so S is directly proportional to number of moles. Basically it is talking about the number of moles of gases. Fourth, what about the pressure? Always remember pressure and volume. So S is inversely proportional to pressure, but S is directly proportional to volume. What about the atomicity? So always remember, entropy is directly proportional to atomicity of a molecule. So what do I mean by atomicity? CO2, how many of the atoms are there? 3. CO, how many of the atoms are there? 2. So atomicity is 2, atomicity is 3. So entropy for CO2 will be more than CO. That's it. Simple, right? Next. All these things are there in any spontaneous process that happens by itself without any external help of the universe, system and surrounding, always increases. For any, if something is happening by itself, means it is telling that the entropy of the universe due to that happening is increasing. How do I say it? See, everything is very, it's a very beautiful relationship. Just you understand it, you know it, that universe is constantly increasing or expanding. And we know that happening of the universe is a spontaneous phenomenon. Of course, everything is there now. So it was thermodynamically told, if something is entropy is increasing, or entropy of the universe is increasing, so that will be spontaneous. Why? Because the volume is increasing, and we have studied about it that entropy is directly proportional to volume. So if the volume of the universe is increasing, means the entropy of the universe is also increasing. So keep in mind, these points are very, very, very important. So delta S universe equals delta S system plus delta S surrounding. Specifically, it means that delta S universe is more than 0, the reaction is spontaneous. If it is less than 0, non-spontaneous. It will not take place without any external help. And delta S equals to 0 if the reaction is reversible and it is at equilibrium. So the entropy of the system will remain constant. Okay, very important, very, very, very important point. Next, these things are there because everyone we know that whenever there is phase change is there, solid to liquid, liquid to solid, liquid to gas, gas to liquid, anything, right? Fusion is there, vaporization is there, sublimation is there. All these processes are equilibrium process. At the equilibrium, delta S equals to 0. Yes or no? Or what we say? Not just, basically it is reversible process, not equilibrium, reversible process. So delta S equals to Q reversible by T, because delta S equals to Q reversible by T. So delta H fusion by T, delta H vaporization by T, delta H sublimation by T. Just that's it. T is the temperature in Kelvin. Next, the another one that's very important relationship, that is delta S equals to NCVM ln T2 by T1 plus NR ln V2 by V1. Very important. But once you use P for at constant pressure, it will become NCPM into ln T2 by T1 plus NR ln P1 by P2. So there I have told you V2 by V1, then for pressure it is P1 by P2, just like for the work done in reversible isothermal process. So delta S equals to NCVM. This is very, very, very important relationship and formula. Please keep in mind. If the temperature, let's say isothermal process is there, it will be 0. Only this will be there. It will be 0. It will be 0. Why so? Because T2 will be equal to T1 and ln1 equals to 0. If it is constant volume, so it will be 0. If it is constant pressure, it will be 0. Then only these part will be remaining, right? I hope you understand it. Next, we are going to talk about spontaneity. What does it mean by spontaneity? Spontaneity means something, if something is happening without any external help, that is spontaneous process, right? For spontaneity, delta S of the universe is more than 0. Second law of thermodynamics. What is second law of thermodynamics? These are the statements. Please read it. One of the very important clauses statement says that no heat without external help can be transferred from cold body to heat body. Of course, spontaneous process from hot to cool, not the cool to hot. But if you want to pass the heat from cool to hot, you will have to give the energy from outside. So you understand it. So one of the statement is second law of thermodynamics, any spontaneous process in any isolated system always result in the entropy of that system. Okay. For the reaction this to this, the correct option is, can you see here, there are 2 chlorine atoms are there, and here it is 1 chlorine gas molecule is there. So 2 moles to 1 moles. So of course the moles is decreasing. If the moles is decreasing, what we can say, entropy is decreasing. So delta S is less than 0. Delta S is less than 0, either this or this. What about this? Can you see that here they were atom, here it is becoming molecule. Molecule is more stable because of the bonding. So what we can say, here energy is decreased. So delta H will be negative. Delta H will less than 0. It is an exothermic process. Dissociation of anything, generally always, dissociation of anything is endothermic, but association of anything generally is exothermic. So delta H is, so here because association is taking place, because here it is association is taking place, so delta H is less than 0 as well as delta S is less than 0. So which is the correct option? Sorry, less than 0. So C is the correct option. Next, for the gas phase reaction PCl5, here it is dissociation. So dissociation means delta H equals to greater than 0. But what about the entropy? 1 mole to 1 plus 1, 2 moles. If the moles are increasing, so therefore entropy will also increase. So delta H is also more than 0, delta S is also more than 0. The enthalpy change for the transition of liquid water to steam. Liquid to steam means vaporization. At is this much. Okay, it is what? Delta H vaporization. What is the temperature? Temperature is 300 Kelvin. The entropy change. So delta S, I have told you, delta S vaporization will be equal to delta H vaporization by T. What is the delta S? I hope you all can see that. Put that, get the answer. That's it. I hope you can do the solution, right? Gibbs energy and spontaneity. What is the Gibbs energy? Always remember that if you want to find out any entropy, let's say spontaneity of anything, why would you go to the delta S in universe? It's a very bad idea, right? So we had to find out a good thing, or you can say a good factor that could explain about the spontaneity. And it was Gibbs free energy change, and that is also known as the maximum work done. You can say maximum useful work done by any system, right? So here delta H comes out to be basically from the Gibbs-Helmholtz equation, that is G equals to H minus Ts. We get the delta H equals to delta H minus T delta S. Very, very, very important. One of the most important thing that you are seeing here. So this is very important relationship. Now always remember it. What is the relationship with delta G, with delta S universe? It is just negative of the relation. So if for any spontaneous process, delta S universe should be more than 0. So delta G should be less than 0. Same, just go opposite. For non-spontaneous process, delta S universe should be less than 0. So delta G should be more than 0. But what about the equilibrium? At equilibrium, delta S universe should be 0. So therefore, here delta G should also be 0. So made a very important and very good relationship, right? So for a spontaneous process, delta S total or delta S universe is more than 0, while delta G is less than 0. These things are there. I told you right now only. So you know it. A relationship between free Gibbs delta Rg and equilibrium constant K. Always remember this is the relation delta G equals delta G naught plus RT ln Q. Q is the reaction quotient, and everyone you know that at equilibrium Q becomes equal to K. That is equilibrium constant, and delta G becomes equal to 0. So at equilibrium delta G equals to 0 and Q becomes equal to K. So therefore by putting it, what you get? Delta G equals to minus of RT ln K. Ln is what? Natural log. If you convert it into that standard log, it will be minus of 2.303 RT log based on K. Okay. So these things I hope you understand it. And in any reaction, delta G of the product minus delta G of the reactant. Final minus initial. Because you know it is what? State function. It is what? State function. And product is the final and it is what? Initial. Because it is, you know that it is final and it is what? Initial. I hope you understand it very well. Next. Effect of the temperature on the spontaneity of the reaction. Always remember, what is that? Okay. Okay, spontaneous at all means it is delta S and this delta H. Always remember one thing, because we know that delta G is negative for spontaneity. Okay, please remember. अभी जो मैं बोलने जा रहा हूँ, it is highly important, and the way I say it, it's going to be very, very helpful for you. Next, please see. If delta H is negative and delta S is positive, so it will be, because you know that delta G equals to delta H minus T delta S. If this is negative and it is positive, negative, so positive of negative will be negative. Negative will always be negative. So this will always be, reaction will always be spontaneous at all the temperature. If both of them are negative, always remember it the way. If both of them are negative, so it is spontaneous at less temperature. Arey, less temperature means what? Kitna less? How much less? So always remember, less temperature. So reaction spontaneous at low temperature. अच्छा, low temperature का मतलब कितना? T less than T equilibrium. अरे अब पूछो सर, what is this T equilibrium? Because we know that at equilibrium delta G equals to 0. So and T becomes equal to T equilibrium. So what is T equilibrium? T equilibrium is nothing but delta H by delta S. It is the T equilibrium. So if it is telling about low temperature, so less than T minus T less than T equilibrium. If both of them are negative, sorry, if delta H and delta S at high temperature, reaction is non-spontaneous at high temperature. I hope it is very easy. Positive, if both are positive, so reaction will be spontaneous at high temperature. It's बहुत easy है. If both are negative, at low temperature. If both are positive, at high temperature. So reaction will be reaction will be spontaneous at high temperature. Means how much high? When T is more than T equilibrium. Now, if it is positive and if it is negative, if delta H is positive and delta S is negative, never ever spontaneous, because all of time, every time it will be non-spontaneous. Always non-spontaneous. Always non-spontaneous. Next, following reaction occurring in an automobile. This is the reaction that is occurring. The sign of delta H, delta S and delta G will be. Can you see that? How many number of moles of gases are there? Can you see? 2 plus 25. The number of moles are 27. It is the number of moles of gases. Here how many number of moles of gases are there? 18 plus 16 is how much? 34. The Ng of product is 34. If the number of moles of gases are more in the product, so delta Ng is more than 0. So of course delta S will be positive. So delta S is going to be positive. Okay. What about delta H? Can you see delta H? Here combustion is there. And in combustion process, all the combustion processes are, always remember, combustion processes, delta H is negative. It is exothermic. So delta H is what? Negative. What about delta G? Here delta H is and delta H is negative. And we know that when delta H is negative and delta S is positive, the delta G is going to be negative. Always spontaneous. Yes. So, okay. And it will be negative. So negative, positive, negative, negative, positive, negative. Option B is the correct option. Next, third law of thermodynamics, useless for you, but still remember it. It states that substance which is perfectly crystalline at absolute temperature, absolute zero temperature, the entropy becomes 0. That's it. So here, these are the things. Please read it. That's it. For the reaction this to this, delta U equals to 0, delta S equals to 0. At this, hence delta G will be what? Okay. Can you find out if the delta U is given? Can you find out delta H? Delta is delta U plus delta Ng into RT. From here you can find out delta H. Once you get delta H, delta S is already given. So you can say delta G equals to delta H minus T delta S. Delta S is given, T is given, delta H is you have found out from here. You can do it. Easy. Next, according to the third law of thermodynamics, which one of the following quantities is a perfectly crystalline solid? 0 at absolute 0. We have studied about it. Third law of thermodynamics. T LT. Third law of thermodynamics by entropy is 0. Next. Now we have come to the thermochemistry. Though we are a bit late, but still we can complete it. What is thermochemistry? Thermochemistry, only few things are very important. Keep in mind. Reaction enthalpy, because you know that enthalpy is a state function. So it will only depend on the initial and final product. So delta H of the product minus delta H of the reactant. Product minus reactant. Final minus initial. It will be what? Delta H of the reaction. Okay. Always remember, we call it delta RH. Next. I hope you can see that this is the reaction. See, this is okay. Just go through it. Not a big deal. Standard enthalpy of formation. Always remember, one of the most important enthalpies are enthalpy of formation. What does it mean? What is the definition? Very important definition. The definition says that amount of energy exchange or the enthalpy change during the process of formation of 1 mole of any substance. अच्छा कोई भी चीज बना रहा हो, कितना बनाना है? 1 mole. 2 mole नहीं, 3 mole नहीं, 0.5 नहीं, 1 mole. But from what? From the elements that it is made up of. Let's say any substance is there. Let's say CO2, carbon and oxygen. So you have to make it from carbon and oxygen only, but they should be in their reference states. What is the reference states? Reference states are fixed. For carbon it is graphite, oxygen ke liye gaseous, not liquid, not solid. So if you are trying to make water, how much of water? 1 mole, not 2 moles, not half moles. Hydrogen gas, oxygen gas. Next, CH4 gas. Carbon should be solid, that is sulfur, that too graphite, and hydrogen should be gas. How many of the hydrogen is needed? 4. So how many moles of hydrogen? Here you are going to take 2 moles of hydrogen molecule. I hope you understand it, what I am trying to say. Okay, chalo, let's talk about SO2. SO2 को बनाने के लिए we need, SO2 gas को बनाने के लिए we need sulfur, but sulfur in its reference state is S8 rhombic. How many sulfur we want? 1. So 1 by 8 of acid. Plus how many of the oxygen? O2. That too in the gaseous state. It is what? Delta HF. Otherwise it is not going to show any kind of heat of formation. Okay. Now one more thing. By convention, standard enthalpies of formation, always remember, if there is any reference state element is there, oxygen in O2, hydrogen in H2, nitrogen in N2, fluorine in Cl2, any metal in like sodium as Na, iron is Fe, whatever, you understand it. If it is in the reference state, like phosphorus in P4 white or sulfur in S8 rhombic, so in all these cases, or mercury in mercury liquid, इनको बनाने के you do not have to do anything. To form them, you do not have to do anything because nature has given it as it is. So therefore, delta H is going to be 0 for that. So delta HF, heat of formation is going to be 0 for that, as well as delta G is also going to be 0 for that. सब तो बता दिया मैंने, और क्या चाहिए? So for element in its reference state is taken as 0. ठीक है? Now and then you just use this relation, this reaction. That's it. Easy हो जाएगा यार. Now Hess law says what it says. It says that if there is any process is taking place, let's say A to B, if you have to convert from A to B, if there are many finite steps you are taking from A to B, let's say A to C, C to D, D to E, E to B, right? So if let's say that lot many steps you have taken, so whatever is the energy exchange is taking in all the separate steps, if you sum up all of them, it will be equal to the direct change from A to B. So either once any change is taking place in one step or multiple steps, the sum of all the multiple steps enthalpies will be equal to the direct change, enthalpy change. Okay. Now it is only the Hess law. Let's say A to B, it is delta H, A to C, C to D, D to E, and delta H1, delta H2, delta. Ultimately, it is indirect. So at 1 plus 2 plus 3 will be equal to delta H. That's it. It is the Hess law. I hope you already know about it. Why am I explaining so much? Hess law of constant heat summation. These are few questions. Whatever is the relationship between the reactions, the same relation will be with the heat of, or you can say enthalpy change. Here zinc plus half of O2 equals to zinc oxide. It is given. Hg plus to giving this to this. Okay. Heat of reaction this. And what is the zinc plus HgO? Just it is for something that it is telling you to find, or you can say it is the master reaction. It is what? Master reaction. Just think about the master reaction. What do we want in the left side? We want the zinc. Okay, where is the zinc? In the reaction 1. It is, let's say it is reaction 1. Let's say that this is reaction 2. Let's say it is reaction 3. So what we can say? Reaction 3. Where the zinc we want? We want it in the left side. Where is zinc here? Left side. How many moles we want? 1 mole. How many mole we have? 1 mole. So we are going to take reaction 1 as it is because it is no change. Now HgO. Where we want HgO? Left side. Where in the reaction 2 it is HgO? In the left side only. How many moles we want? 1 mole. How many moles it is? 1 mole. So means we will have to take the reaction to be also as it is. So delta RH3 equals to delta RH1 plus delta RH2. How much is the delta RH1? I hope you can do that. Put these values and get the delta RH3. Easy one. Very easy. Right? Next. Given is carbon plus oxygen given to CO2, and this to this is this. Then what is the heat of formation of CO? CO ke formation ke Ce plus half of O2 giving CO. This is what we want. It is reaction 3. It is what? Reaction 2. It is what? Reaction 1. So how can we get this reaction 3 with reaction 1 and reaction 2? Carbon, we want what? Carbon here. So do we have carbon any other place? Always remember, we have to find out, we have to only see those things or those substances which are coming only once in all the given reaction. So can you see that oxygen is given once, twice. So do not take oxygen here. Only see carbon. Can we see carbon dioxide? Carbon dioxide is also given 2 times. So do not take it. Just think about the C and just think about the carbon and carbon monoxide. So what do we want? Carbon. And what do we want? Carbon monoxide. Where we want carbon? Left side. Where we have carbon? Left side in the reaction 1. What we can say? Reaction 3 equals to reaction 1 as it is. But what else? Oxygen ko mat dekhna. Do not see oxygen because oxygen is coming more than one time. So do not say it. Think about the CO. How? Where is CO? It is in the left side. Where we want? Right side. Okay, means we have to flip it. Flip it means reverse it. So minus of R2. But how many moles we want? 1 mole. How many moles it is given? 2 moles. So to make 2 1, you have to half it. So R2 by 2. So delta H3 will be equal to delta H1 minus of delta H2 by 2. Keep these values and get the answer. One of them will be the correct answer. Enthalpy of combustion of these are this. Then heat of hydrogenation. Now here you have to write all those reactions. Enthalpy of combustion of hydrogen. H2 plus half of O2 giving H2O. Let's say it is given X. Consider this value is what? X. It is what? Y. It is what? Z. And then it is C6H10 plus O2, 6 CO2 plus 5 H2O. For this it is Y. C6H12 plus O2, 6 CO2 plus 6 H2O. Here it is Z. These are the values that we have. And what do we want? Let's say it is R1, R2, R3. And what do we want? We want reaction 4. Where is the reaction 4? Heat of the hydrogenation of cyclohexene. What is cyclohexene? This. So C6H10 plus hydrogen giving C6H12. This is something that we want. How can we get reaction 4 with the help of R1, R2, R3? Can we have any idea? Yes. Do we have? Yes, yes. So reaction 1, what do you want? C6H10 in the left side. Where is C6H10? Reaction 2. Okay, where is hydrogen? Hydrogen is there in the reaction 1 and it is in the left side only. Reaction 1. Where we want C6H12 in the right side. Where we have left side means reaction 3 has to be reversed. Minus of R3. So just do it. Delta H2 plus delta H. What is this? Y plus X minus Z. Just do that. All these values we have kept. Please find out. Now enthalpies of our different types of reactions. Because of the shortage of time, I'm going to pick few of the important ones. Okay. The heat of neutralization of 4 acids A, B, C, D when neutralized against a common base is this much, this much, this much and this much kilocalorie. The weakest among these acids is, which is the weakest one? Because we know that when it is weak acid, the heat that is removed or released is less. Why so? Because rest of the heat is used, or rest of the energy is used for ionizing it, right? So wherever the heat of ionization is least, it will be the weakest acid, because here 13.7, 9.4, 11. Which is weakest? 9.4, because it is lowest. So it is for B. So which is the weakest acid? B. Easy. Always remember the delta H neutralization follows the order: strong acid, strong base is more than strong acid, weak base, or weak acid, strong base is more than weak acid, weak base. Easy one, right? Next. The reaction is given below. Here there is a reaction. What it represents? Can you see that BaCl2 is a salt and it is having few of the atoms of molecules of the water. So it is called, it is the heat of, it is what? Hydration. Yes or no? So what we can say? Enthalpy of hydration. Next, the bond dissociation energy of X2Y to XY. I think there is okay. How many questions do we have? Okay. Some new. Just we can do it. No issues. So here we have been given with the, first of all you have to remember one thing. Delta RH के साथ आपने देखा था delta HF of product minus, it is product minus delta HF of reactant. You did this for heat of reaction. But if it is bond dissociation energy, that is what? E. If it is, you are saying it is bond dissociation energy. So how do you deal with that? Just always remember delta RH equals to bond dissociation energy of reactant minus bond dissociation of product. Please keep in mind. So reactant minus product, not product minus reactant. If it is talking about the bond dissociation energy, then reactant minus product, not product minus reactant. See how, what are the things that we have given? That bond dissociation energy for X2, that is X plus X, Y2 for Y plus Y, XY for X plus Y. What are the values given for this? Let's say it is 1 is to 0.5 is to 1. So if it is, let's say A, so it will be A by 2, it will be A. So consider here delta H value is A, here delta H value is A by 2, and here delta H value is A. Okay, this is something that we have. Now what we want? Now we have to find out the formation. For the formation of XY is this much. Okay, okay. So delta H for the formation is given. For XY, what will be the for XY formation? Half of X2 plus half of Y2 to XY. Whatever is it is telling about anything. So just write the formula for that, because we want to, for formation, how many moles we should make? Only 1 mole of XY. For 1 mole of XY, half of X2, half of Y2. It is what? The value is given, delta H value is given minus 200. So what will be the relation? Very easy. So delta RH, that is minus 200, equals to reactant minus product, not product minus reactant. It will be half of X2 के लिए कितना value है? A. Y2 के लिए कितना value है? A by 2. So half of A by 2 will be A by 4. Minus of reactant product के लिए कितना है? How many moles is there? 1 moles. So what we can say? We can say A. So it is how much? Minus of A by 4. Minus of A by 4 is how much? Minus of 200. Minus minus cancel. A equals to 800. A equals to 800. That is how much? Which is option D. Okay. Now let's go to the next one. Enthalpy change. Enthalpy change for the reaction 4H2 to H2 is this much. Then dissociation energy of HH bond. Dissociation of HH bond will be HH. You can write the reaction like this, 2H. Can you see? It is 4H to H2, or you can say write it as H2 to 2H. It is the bond dissociation energy of HH. Okay. So this is the reaction that it is asking for. It is the reaction that it has given. So how can you see that this is just, first of all, let's say that this is reaction 2, and it is what? Reaction 1. How can we get this reaction 2 with the reaction 1? So reaction 2 may, we want hydrogen atom in the right side, where it is in the left side. So we have to do minus of R1, means reaction 1 ka just opposite. But here we want 2 moles, here it is given 4 moles, so means we have to do half. So here delta H will be equals to half of minus 869.6. So it will be plus, minus minus plus 400 something. So option D should be the correct one. And then given the bond energies of HH, Cl, Cl are this and this, then what is for HCl? I can just, I'm giving it for you to solve, just solve it. For delta HF, H2 plus Cl2 giving HCl, half of, you can just use this, and it is the delta HF of HCl. And how can you do it? Because you know that it is the reactant, half of H2 ka bond dissociation energy plus half of Cl2 ka bond dissociation energy minus of HCl ka bond dissociation energy. You will get the final answer. That is it. You can do it very easily. So that is all. So everyone, thank you. And one more thing, please, it is the final days are there, so please take care of you, take good care of you and good care of your health. Stay hydrated and stay motivated, and all the best for the NEET examination. Thank you.